Okay. Okay, we're good.
Cool. So Josh is here. I'm here. I'm gonna take this because my son is on here. So I can
Get it. Sorry, my dog is sleeping. Okay, we're good.
I got that time. I was trying to figure out that was birds or a kid, but it's a dog.
No, he was destroying his Chewbacca toy here. So, hey.
Or Chewbacca.
I know.
Okay. So problem 1. Question.
I want to know how they got 130, or I know how, but why for A on 136?
Well, they were asking for the total number of chromosomes, and so since it was tetra, you had to divide the total number you had, 68, by 2, and then multiply that by 4. That's how I did it at least.
There's 2 sets.
Yeah.
Oh, that total 68.
So it's asking how many sets of chromosomes.
Well,
because a tetraploid means there's 4 sets. There's 68 per set.
No, there's 68 total in your 2 given sets.
Okay. So
it
should be 8 times 4.
Times 2.
Yeah, the 68 was like if that was like a normal individual. So a 4N would just have twice as much of that.
So normally
So it's just double.
Yeah. Like this is basically saying if there's 34 chromosomes or 34 sets of chromosomes, right? Then you would have 68 total chromosomes in a normal individual.
Okay.
So a tetraploid, instead of having 2 sets, you have 4 sets.
4 sets. Okay.
Or, well, 4, not, sorry.
I was thinking
instead of having 2 per set, you have 4 per set.
Yeah.
But you still just have your 34 sets.
This up, so. It's because it's 4N, right?
Yeah, and in this case, N would be 34.
N is the number of chromosomes within a set. Okay, so it is per. That's what threw me off, and I missed the within a set. And I just didn't look it up afterwards because I was thinking it meant that's the number of chromosomes, period, which would have made it 72.
Well,
but within a set, so it's half that.
There's 68 chromosomes total, meaning there's 34 sets of chromosome in the normal individual.
So I just had double mine.
Okay, yeah.
Okay, that's the only one I missed there.
Okay. The next one, it's disomic for chromosome 5, which just means it's normal for chromosome 5 with the rest. So we're still at 68, right?
Yeah.
Trisomic just means it's got 1 extra chromosome for that set.
Extra 17 on that.
So you got 69.
Yep.
Right. Monosomic, you're missing 1 from a set, so you lose 1. So you're
Yep, 67.
Reciprocal translocation between chromosome 5 and chromosome 17 just means that those 2 got mixed up, but it doesn't change how many you have, right? So you should still have 68.
Yeah. I actually have one of those with me.
Okay, next question. Which of the above terms is associated with Patau syndrome? That was just again from the reading, right?
Which is aneuploidy and trisomy. And then I wasn't sure about the non-disjunction.
It says non-disjunction. I didn't get that.
I had it as a question mark because it doesn't say it in the reading.
Yeah.
But
well, because if you have a euploidy, it's because of non-disjunction.
Okay.
So any of those cases are going to have non-disjunction with them because you're getting an extra chromosome, and that's how you get that.
Okay.
Okay.
We can live with that. Next one, which of the above terms is associated with conventional form of Down syndrome? Aneuploidy, trisomy, and non-disjunction.
Yep.
I've got trisomy and non-disjunction. I didn't get the aneuploidy, but that makes sense.
It's in aneuploidy because it's trisomy.
Yeah.
Down syndrome is trisomy 13?
Yeah, something like that. C, which of the above terms is associated with Turner syndrome?
Monosomy.
Monosomy, aneuploidy, and non-disjunction.
Yep.
So, yeah, I missed one of those too. I'm not doing the reading though. D, which of the above terms is associated with
Cru-du-Chat.
Is that Cru-du-Chat, or how do you say that?
Cru-du-Chat.
Cru-du-Chat. I've got deletion.
Yeah.
Okay, that is right.
Yeah. So it's the deletion is all.
Yeah.
And I also had that was non-disjunction. was wrong.
Or anything. Nope.
And that's what I said.
Familial Down syndrome is just reciprocal translocation.
Yep.
Yeah.
Cool.
And it doesn't have any of the others, I guess. So, yeah.
For 3, so basically we all read that thing, so then it's just what are the products of those gametes, I guess?
Of those crosses.
Yeah. So the first and the last one makes sense as far as like the normal ones.
Yep.
For the middle one, or the middle ones, I was curious, how do you know what the mixture is going to be, if that makes sense?
Okay, so she had a video on this.
Oh, I didn't watch it.
And so the way she had it explained here is she lined them up by the E's and the F's. Because in the problem, it said that there's a crossover between the E and F alleles. So she just lined them up.
Oh, that makes sense then. I
So
missed that portion.
She lined them up at the E's and the F's,
Yeah.
and she went ONMLK centromere, JICDE, FGHIJ centromere, KLMNO.
ONM.
And on her, the answer key is backwards.
Yeah.
Because she went from the O here
Yeah.
this way. I went left to right. I don't think that means the answer is wrong at all.
No.
I don't think it matters which way you go.
So because it said
Just line it up on the E and F, and then
everything to the right of one of them and everything
Yeah.
to the left of the
so
other.
so it goes up this one, and then it crosses over to this.
Yeah. Okay.
And then here, and it crosses over to there.
Okay, that makes sense. I missed that detail, and again, I was just in a rush, but I missed that detail where it said between the E and the F, so I wasn't sure about. I was like, yeah, I know that there is a cross, and I just didn't know where that would happen.
Yeah.
But that makes sense now.
Mm-hmm. And then it says, which of the 4 expected to produce viable offspring?
1 and 4. I
And-
got
Let me look at the.
that.
I've got them in different order.
Well, just
Like,
the 2 normal
the-
ones.
so the two normal,
that were
yeah.
not changed. The 4 contain deletions or duplications, the ones that aren't normal.
And I said, well, yeah, you can look through and see that this one's missing all these little the lowercase and
Which is going to be whichever 2
Yeah.
aren't like the parentals.
exactly.
And then which of the 4 chromosomes are acentric or dicentric?
Mm-hmm.
That's
3 or my 3. This one is acentric,
yeah, the one that
Because
has
it
that
has
shorter
no
with no
centromere.
centromere. Yeah,
and then the other one's di because it has 2 centromeres.
Yeah. which makes sense. Cool. An individual who has suffered a reciprocal translocation possesses the following chromosomes. Shows them. So then question A, suppose that the translocation cross undergoes the alternate pattern of segregation and meiosis. 1, what is the chromosome composition of the 2 daughter cells at the conclusion of meiosis?
Yep.
Please indicate the alleles that are present in each.
You know how to do those ones? Did you get that?
That one was really just like reading the description and doing it that way. Because like
Let's see.
first one, like in the description, it tells you about how normal goes with the normal one, and the translocated one will go with the translocated one. For alternate. And then for the next one, for the adjacent one, he was talking about how the top 2 and the bottom 2 are going to segregate together. So I just lined them up and did it that way. And then adjacent to was just the left side going with the left side and the right side going with the right side.
So I saw that diagram. You just set it up in that weird cross thing. How do you know?
I mean, this is how I wrote it. I just did. Can you see that? Like, I just lined them
not
up
focused.
together.
Okay.
And then went from there. I just lined the parents up
Yeah.
and looked at it that way. That was the easiest way for me.
I'm not sure how to know which one is the alternate compared to the adjacents? That was the one question I had on those.
Yeah, so the alternate, they're diagonal. So like in my lined up one, you have the one on the left side is like your parents, your A, B, C, D, E, F, G, H, I, and then your translocated one. And then
So how did you line them up?
I just put both of the A, B, C, D ones on one side, one on top of the other, and the RS is on the other side. So then if you just do it diagonally, that's going to be your alternate. And so that's going to end up with your translocated ones together and then your normal ones together. And those are going to be your two options.
Okay.
And for the adjacent number 1 is just the top two to go together. So your A, B, C, D, E, F, G, H, I, and then your translocated RS will go together. And then the bottom two. Okay. And then for the adjacent number 2, it's just the 2 on the right. So you'll end up, one of them is going to end up with all of the A, B, C, D, E alleles, and the other one's going to end up with all the RS ones.
Okay. That makes kind of sense. The diagram I used to figure it out was mine.
Wait, so individual transcriptions has 1 chromosomes. So those are the original 4 chromosomes. So why do you have 8 chromosomes? Oh, because it's in meiosis 1, so they've all duplicated.
Yeah. So this is the diagram I went off of. Was this right here. Hold on. So I can zoom in. And so you have originally 5 and 14. And he did it where there was 1 here and there's the translocation in it. Yeah. Okay. And so you drew it out. And then
they each duplicate. Makes sense.
They each duplicate and they go like this. And looking at this, you have the alternate. The alternate is the brown. So if you look in, you'll kind of see this is the brown. This one right here, this circle, and this circle. So those 2 are the alternate. And then these 2 are alternate. And they go here, and then they form those 4 gametes, which are 100% viable. The adjacent is the blue, which is top and bottom. They go and they form these, and it simulates duplications and deletions, non-viable gametes and or offspring. And then adjacent 2 was the side ones. My question though was I wasn't sure which one to put where.
When setting that.
When setting this up.
I'll be honest, I was really poorly prepared. I didn't read through this well at all, so I'm not the one that answered that question.
No, but I the way she explained it, and I'm now that I'm actually discussing it, the 2 normal are opposite, and then the 2 translocated are opposite.
Okay. So then, what's I guess like the purpose of this? So I'm just curious because you've got drawn 8 chromosomes. She only has 2 cells being created. So like because for the answer, cell 1 and cell 2.
Yeah. So
like where do those alleles go?
When it says identify the allele composition of the gametes produced by alternate segregation, it's asking for these down here.
Yeah. So there's actually going to be 4 cells that form, but you only have 2 options. 50% of them are going to be one way, and 50% is going to get the other way. So she was just asking for the 2 different arrangements that the 4 different cells are going to have.
I highlighted the colors. So the blue and the brown will both go off, and they'll form the 4 or the 2. So 1 blue and 1 brown will come together.
Okay.
And then, so technically, that'll be 2 different gametes produced by that.
Yeah. Yeah.
And then this one is just 2 gametes produced by the other 2. So this one will go with one of them, and the other one will go with the other, producing a total of 4 between those 2.
Okay.
Is the possibilities.
Where's the question?
So it says, suppose that these two pairs of homologous chromosomes replicate prior to
Yeah.
meiosis, producing 8 total sister chromatids.
Okay, yeah. So
The 4 replicated chromosomes then attempt to synapse during prophase 1. And this is, so it's saying diagram the synapsis.
4 replicated.
Yeah.
Okay.
Diagram the synapsis of the chromosome in prophase 1. This is the synapsis. Just
So you're only looking at the 4 inside ones?
Yeah.
I see.
And I
Not
guess
looking-
technically,
Also, though, her answer key is not the same as what the question asks.
and technically, so this here would be, you go here, you have the cell, and you have your synapsis there. And then you have the things that attach to the chromosome, yada yada.
Yeah.
These are the chromosomes.
Okay.
And so this will pull this way and this way. Well, then, kind of going down along with these on the last question, how it pulls, starts off with the 4, and they
Yeah.
are pulled separate ways.
Yeah.
That's what it's. Go.
I need to follow on chromosomes. So things on here. Her key is different than what the questions are asked.
Oh.
That's why I was confused. Okay.
Okay.
Okay. Yeah. No, this makes more sense now. I was looking at the key instead of the. Okay.
Well, her key skipped the first one, the synapsis, and she just went kind of straight into the crosses.
Oh, I see.
Yeah.
Well,
And then the last one doesn't have an answer.
Yeah, you were just supposed to draw meiosis, though. It wasn't.
No, it was. Yeah, it wasn't complicated.
You just had to do it with non-disjunction.
How many? So what did you get as the offspring for meiosis 1?
Well, you should have 2 that only have 1, I thought.
The 2 monosomic and then 2 trisomic.
Yeah, 2 that have an extra 1 and 2 that have 1 less.
Okay, and that's what I got as well. And then what about the end of 2?
That one, there's 2 that are normal, and then there's 1 that has 3 and 1 that has 1.
And that's what I got as well.
yeah.
Okay.
Keep in mind, it's not the gamete, so the final production
Well, yeah.
isn't trisomic.
Yeah.
It would be, well, I guess,
Well, no.
yeah. Anyways, yeah, it does have an extra. That's the main point.
Yeah.
So basically, it's going to have. Yeah, okay, I see, yeah. Cool.
Yeah. Any other questions or anything, or are we good?
I'm good.
Good.
Is she going to be okay with the
It's 30 minutes.
where's the 30 minutes?
Yeah,
All right,
that was funny. Okay.
Bye.
See you next week.
Bye. Yep.